Could we detect cancer before a tumor even forms? What if the deadliest thing about cancer is not the cancer itself, but the fact that we usually find it too late? By the time many cancers are discovered, a tumor is already visible, symptoms have already started, and in some cases, the disease has already spread. So here's a wild question. What if we could detect cancer before a tumor even shows up on a scan? Maybe before there's a lump, before pain, before the disease has a real chance to take hold. It sounds almost impossible, like science fiction. But scientists are getting closer to something that may be just as powerful. Not detecting a giant tumor early, but detecting the molecular warning signs that appear before cancer becomes obvious. And that could change everything. First, we need to clean up the question: can we truly detect cancer before a tumor even forms? Not exactly in the simple way that phrase suggests. Most of the exciting new blood tests in development do not detect nothing. They detect signals coming from abnormal biology that is already happening inside the body. That could mean fragments of DNA, strange chemical patterns on DNA, unusual proteins, or other warning signs being released by cells that are starting to go wrong. So in a strict sense, these tests are not detecting cancer before anything exists. They are detecting the earliest smoke from a fire that may still be too small to see. And that is still incredible, because today, cancer is often found after it becomes large enough to show up on imaging, cause symptoms, or trigger concern. But what if one day a routine blood test could raise the alarm while the disease is still microscopic? That is the dream behind what are often called multi-cancer early detection tests. Imagine going in for an annual checkup, getting your blood drawn, and instead of only checking cholesterol or blood sugar, the lab also searches for tiny traces of abnormal DNA or other molecular fingerprints linked to cancer. Not one cancer, many cancers at once. That is why people are excited. It suggests a future where medicine does not just react to cancer after it becomes dangerous. It starts looking for cancer while it is still quiet. And in some cases, this future may already be starting to peek through. In one study led by researchers at Johns Hopkins, experimental blood testing found tumor-related mutations in some stored blood samples more than 3 years before diagnosis. Think about that. Not 3 months, not a few weeks, years. That does not mean doctors can now routinely detect every cancer years in advance. They cannot. But it does mean the body may sometimes leave a detectable molecular trail far earlier than we once thought. That opens a huge door, because if that warning window is real, then the future of cancer care may not begin with better chemotherapy. It may begin with better detection. But now the story gets even more interesting. Cancer does not usually appear out of nowhere in one dramatic moment. It is often the result of cells slowly drifting off course. Mutations build up. Control systems weaken. Some abnormal cells die out. Others survive. A few keep evolving. And here's the hard part. Not every abnormal cell becomes cancer. In fact, as people age, small groups of cells carrying cancer-related mutations can appear in tissue that still looks normal. Many of those cellular mistakes may never become a tumor. So the challenge is not only finding abnormal biology early. The challenge is figuring out which early signals are harmless, and which ones are the beginning of something deadly. That is a massive difference, because nobody wants a future where millions of healthy people are told, "Your blood test found something strange," only to spiral into fear, scans, biopsies, and procedures for a threat that was never going to hurt them. So the real breakthrough is not just sensitivity, it is meaning. Can a test tell the difference between a harmless warning light and a real emergency? That is where some of the newest research gets fascinating. Scientists are not only trying to find more cancer signals, they are trying to find better signals. One promising approach looks at something called epigenetic instability. That sounds technical, but the basic idea is simple. Your DNA is not just a code. It also has regulatory markings that help control which genes turn on and off. In healthy cells, those control patterns are usually stable and orderly. In cancer, they can become chaotic. So instead of only asking, "Can we find tumor DNA?" researchers are starting to ask, "Can we detect the instability that appears when cells begin losing control?" That is a profound shift, because it moves the question from, Can we find cancer once it is there? 2. Can we spot the biological chaos that comes before cancer becomes obvious? And that may be the real frontier. But before we get carried away, we have to stay honest. This field is promising, but it is not magic. A blood test can miss cancer. A blood test can falsely alarm. And sometimes a signal found in blood does not come from a solid tumor at all. There is even a known problem called clonal hematopoiesis, where aging blood cells pick up mutations that can look suspicious on a test, even though they are not evidence of a tumor somewhere else in the body. So even if the technology gets better, one major problem remains. If a blood test says something is wrong, what do you do next? Where do you look? Which scan do you order? How do you confirm it? And how do you avoid hurting people with unnecessary interventions? Those are not small details. Those are the questions that determine whether a breakthrough helps society or creates confusion. And that is why the road ahead is both exciting and difficult. Some blood-based screening tools are already real. For example, there is now an FDA-approved blood test for colorectal cancer screening in certain average-risk adults. That is a major step. But even there, the story is nuanced. A test may detect existing cancer reasonably well, while still being far weaker at finding advanced precancerous lesions. And that matters, because one of the greatest strengths of something like colonoscopy is that it can actually remove precancerous polyps before they turn into cancer. That is a huge point people often miss. The future is probably not one miracle blood test that replaces everything. It is more likely a layered system. A blood test for early molecular warning signs. A scan when needed. Targeted screening based on age and risk. Traditional tools like colonoscopy or mammography, where they still do the job best. And eventually, smarter models that help doctors predict which invisible changes truly matter. In other words, the future of cancer detection may not be one machine. It may be a network. A network designed to catch disease earlier, classify it better, and act before the worst stage ever arrives. And if that happens, the biggest revolution in cancer care may not be a new drug at all. It may be timing. Finding danger sooner, intervening earlier, stopping progression before the disease becomes visible, painful, and life-threatening. So, could we detect cancer before a tumor even forms? Not in the clean, sci-fi way that phrase suggests. But could we detect the earliest dangerous biological signals before a tumor is visible on a scan? Could we identify precancerous change? Could we sometimes catch the molecular smoke years before diagnosis? More and more, the answer looks like yes. And that may turn out to be one of the most important shifts in modern medicine. Because the best way to beat cancer may be to catch it so early that it never gets the chance to become the monster we fear.